according to Einstein's special relativity theory, the time can slow down, and I will explain to you why it happens and how it happens, so that you understand what the relativity theory is telling you about. Okay. Now, suppose the rocket go out from Earth, say control center in Houston, and heading to a planet at the speed v. Okay, so the Houston have the local clock and also has a clock to monitor the rocket. Okay, so what happened is, when the rocket is going at the speed v, say Houston clock advance 20 minutes, right? Then rocket clock monitoring may advance only 15 minutes. That's what it means, time slow down. Why it happened? Okay, the cutting into the core of the theory, it show you how the time is expressed in the relativity theory. The T1 is a local time. T2 is a time on the rocket. Okay, there is a ratio, lambda, is in this equation. Now, we talk about only problem on the control side. We talk about rocket side later. Okay, so what is lambda? The lambda is given by this, and now it's a little complicated equation, but basically when rocket is flying at the v and there is a maximum speed c, its ratio is going to determine the lambda. And since maximum speed is c, this is going to be less than 1, and 1 minus something less than 1 is going to be less than 1. Square root is less than 1, so 1 over less than 1 is going to be bigger than 1. So suppose you have a 20 minutes pass, right, in Houston, T1 minus T1 prime. You use this equation, then lambda T2 minus T2 prime will be lambda delta T2. This is only 15 minutes. The discrepancy is taken care of by this lambda. This is called the time dilation. Okay, and it's happened in inertial system. What inertial system is? The things moving at the constant speed. There's no acceleration. And special relativity theory is all about the constant speed. Okay, I said c is the maximum speed. Many people misunderstand Einstein's theory is about light speed. It's not about light speed. Okay, he simply said there is a maximum speed things can go. Things, what is things? Mass or energy. Okay, energy particle, photon, can go at the maximum speed. But there are a couple other things. This is Einstein claim is supposed to go maximum speed, like a boson or graviton. Graviton is a gravity wave. And why they go maximum speed? Because they don't have mass. Okay, well, nobody measured the speed of bosons or graviton, the gravity wave, so we don't know. Actually, it's still conjecture. So only one we know that run at the maximum speed is light, and that's why we always use light as a representative of the maximum speed things. Okay, but theory is not about light, it's a maximum speed. Okay. Now, this is only half of the story. The theory, okay, we have to take care of the rocket side because we went through only half of the theory. So what's happened is, in Newton's world, there is a reference point somewhere and tells you X, Y, Z. The Newton has X, Y, Z, and a Kroc. Centrally organized coordinate and clock. So Newton can tell who is moving, who is not moving. Say Earth is not moving, rocket is moving at the speed v. So everything is under control. And this kind of claim that the clock start ticking at a different speed never happened. Okay, Einstein removed this one. So there's no central reference. So now we don't know who is moving. For example, when rocket going at the speed v, you claim that that's only what people said on Earth. If you are inside a rocket, what's happened is, oh, Earth start moving away at the speed of v, right? So it's a relative, depend on who the observer is. It's called reference frame, the observer. Observers, you have to care about who is the observer. This central control, Newton's system, you know, the observer is a god and knows everything about who is moving, who is not moving. But in Einstein's world, there's no central control. Everybody is relative. Depending on who you ask, what is moving is different. So, on the rocket, we have rocket local time, okay? And we also monitor Earth time. So what's happened is 20 minutes pass flying at the speed of v. The rocket said 20 minutes passed, but it said, strange, Houston the clock goes only 15 minutes. What's going on? Okay, so rocket has its own equation. By the way, this equation is made by Lorentz transformation. It's just Einstein made it physical theory out of this equation, and now everything clear under Einstein theory. What's happened is, rocket said time start clicking slow on Earth. So for sure, he said Earth is moving away at the speed of v. Well, it ridiculously seemed to be, but you know, it's depend on who you're talking to. The control center said, well, rocket is moving away at the speed of v and their clock is slowing. Okay, so it's fair, right? But control center thinks rocket clock is slower. The rocket, inside the rocket, astronaut thinks the control center's clock is slower. Are they contradicting? Think about it. Well, actually it's not. Okay, it's like when you have your friends far away, you shouted to him, hey, you look so small. Then your friend shouted back, hey, you look so small. Are they contradicting? Well, you know, who is smaller? Now, you have to ask who. You give this question, who is smaller? If you ask yourself, your friend is smaller, and this is perfectly fine. Physically, you know, perspective issues, your friend should look small. If you ask your friends, you are smaller, because that's in his side of physics perspective. I should look smaller to him. So there's nothing violating physical law. So this Kroc set and this Kroc set each conform with physical law. Okay? So Einstein's important theory here is every moving system, and at the constant speed it's called inertial system. Okay? The physical law is valid on each system, and you cannot compare. Suppose you bring the third party. Okay, there's another rocket that goes at half speed. I'm in the middle. Okay, so I'll be the good judge. I will tell you whose Kroc is wrong. Okay, so if he monitor the rocket, then it's still slow, but not by 15 minutes, 7.5 minutes. But if he monitor Houston, the Houston Kroc is slow, but not 15 minutes, 7.5 minutes. So Houston's Kroc and rocket Kroc match up, perfectly synchronized for the guy flying at the half speed. So you have to ask the question, who you should ask to compare the Kroc speed. Okay, if you ask a guy in the rocket, Houston is slower. If you ask a guy in the Houston, rocket Kroc is slower. The guy you ask flying at the half speed, he said both are slower, but both are same speed. Okay, so that's the Einstein's time dilation. So here's an interesting twin paradox. Okay, suppose we have a twin, and one guy left Houston, go to the planet, and Kroc is slow, and when he arrived planet, about 5 years of delays recorded. Now he go around and come back, so another 5 years delays are recorded. Now when he go around, the clock on the rocket broken, so he doesn't know what's going on. When he come back and meet his twin brother, what's happened? Think carefully. Now he is on the Earth. He is joined to be Houston observer, so he need to be seeing the same thing as people in Houston, which is the difference is 10 years. So my God, he came back and see the brothers. What's happened to your hair? You're already old. Okay, he came back to the future, but his twin brother on Earth said, what's happened to you? You're still so young. Well, he came back to the past. Okay, so he looked at his brother, it's a past. So they each other goes to future or past. That's what is happening. Okay, that's called twin paradox. Actually, it's not paradox. It's according to the theory. It's possible. Now, I tell you why Kroc is broken when it's go around the planet. Okay, the going around the planet, it's change the speed, and the speed doesn't matter which way it's go, this way or that way. The Kroc delay for people in Houston. Now, going around, there is an acceleration, and acceleration is not relative, and this comes in Einstein's general relativity theory. Acceleration is not inertial system, and if you have an acceleration, you can tell who is getting acceleration, rocket or Houston. Rocket go around the planet. Rocket obviously get acceleration, not the planet. Okay? So if I say, hey, I'm flying away from you with some acceleration, okay, then it looks like he is flying away from me with some acceleration, but you can tell who is getting accelerated, me or him. Okay? Acceleration is different. So only rocket experience something else by the acceleration. And general relativity theory said acceleration is also going to slow down the time. So what happened is his local clock, this local clock is going to slow down, but he doesn't know that's the clock he sees. Okay? So if they are monitoring, it slow down even more. So what happened is he has some additional slowdown by the acceleration, and when he come back, then he's young. His twin brother is older. Now here comes a Grampass fallacy. Now, well, it's often said that if you go back to the past and kill your grandpa, what's happened to you? You wouldn't be born, so it's a contradiction. Well, this never happened under this Einstein's theory. See, Einstein's theory said, okay, suppose you left grandpa, your parents, and you left somewhere, right? Oh, grandpa left after having your parents to the space trip and come back to the future. Can grandpa come back to the future? So what happened? Grandpa come back and see, hey, grandson here. Okay, now you kill your grandpa here. So what's happened? Nothing happened, because before he leaves, he had a parents already, and grandpa's parents, your parents, grandpa's kids, have you here. So it's grandpa meets you. That means you are going back to the past. Grandpa is coming to the future. Okay, now you kill him, nothing happened. You are still here. Okay, so that's a general answer to those fallacy and the paradox. And there are additional things, like we talk about mass, and contraction. Contraction means everything in the spaceship looks shorter for the observer in the control side. Okay, and also spaceship mass increase. So that's a problem. According to this equation, the mass start increasing like crazy. When the speed goes close to the max speed, then the mass become infinity. So you can never achieve max speed. The only way you can go max speed is massless particle like gravitons and light. So from our viewpoint, clock on the light is stopped. It never moves because it's always moving at the light speed. So there are many other interesting things we can talk about based on this equation. But this is at least you get correct understanding on what Einstein theory is about. Okay, we have other physics video. Please check it out. Thank you.